Translational and rotational mechanical systems. There are two types of mechanical systems based on the type of motion. The first one is translational mechanical system and the second one is rotational mechanical systems. Translational mechanical system move along a straight line. The three basic elements of translational mechanical systems are mass, spring, dashpot or damper. If force is applied to a translational mechanical system, then it is opposed by opposing forces due to mass, elasticity and friction of the system. Since the applied force and the opposing forces are in opposite directions, the algebraic sum of the forces acting on the system is zero. Let us now see the force opposed by these three elements individually. Mass. Mass is the property of a body which stores kinetic energy. If a force is applied on a body having mass m, then it is opposed by an opposing force due to mass. This opposing force is proportional to the acceleration of the body. Assume elasticity and friction are negligible. Spring. In this diagram, F equal to Fk equal to K of x, where F is the applied force, Fk is the opposing force due to elasticity of spring, K is spring constant and x is displacement. Dashpot. In this F equal to Fb, which is equal to b into dx by dt, where F suffix b is the opposing force due to friction of dashpot, b is the frictional coefficient, v is velocity and x is displacement. Modeling of rotational mechanical system. Rotational mechanical system move about a fixed axis. The three basic elements are motion, moment of inertia, torsional spring, dashpot. If a torque is applied to a rotational mechanical system, then it is opposed by opposing torques due to moment of inertia, elasticity and friction of the system. Since the applied torque and the opposing torques are in opposite directions, the algebraic sum of torques acting on the system is zero. Let us now see the torque opposed by these three elements individually. In translational mechanical system, mass stores kinetic energy. Similarly, in rotational mechanical system, moment of inertia stores kinetic energy. If a torque is applied on a body having moment of inertia J, then it is opposed by an opposing torque due to the moment of inertia. This opposing torque is proportional to angular acceleration of the body and it is negligible. Torsional spring. In translational mechanical system, spring stores potential energy. Similarly, in rotational mechanical system, torsional spring stores potential energy. If a torque is applied on torsional spring K, then it is opposed by an opposing torque due to the elasticity of torsional spring. This opposing torque is proportional to the angular displacement of the torsional spring. Assume that the moment of inertia and friction are negligible. In torsional spring, T equal to T suffix K, which is equal to K theta, where T is the applied torque, T suffix K is the opposing torque due to elasticity of torsional spring, K is the torsional spring constant and theta is angular displacement. Dashpot. If a torque is applied on dashpot B, then it is opposed by an opposing torque due to the rotational friction of the dashpot. This opposing torque is proportional to the angular velocity of the body. Assume the moment of inertia and elasticity are negligible. The assessment question is given in this slide. And thank you. In this dashpot, T equal to Tb equal to b d theta by dt, where Tb is the opposing torque due to the rotational friction of the dashpot. B is the rotational friction coefficient. Omega is the angular velocity and theta is the angular displacement. Thank you.